Hi everyone. In this video, I will tell you about how to specify partial frame fixity in ETABS. There is no simple option in ETABS to just release a specific percentage of moments at the supports. The only way is to do by calculating and entering a spring stiffness value or reduced stiffness of members, which you have to calculate manually. So for this case, I am considering a beam which is fixed at both ends and carrying a UDL of 15 kN per meter. So the length of beam is assumed as 5 meter. To avoid the self-weight of section, I would just change the density of existing material to 0 by modifying the material properties and define menu section. So first let me click to the new model. So I will select metric SI system. Okay, as I am selecting the length of beam is 5 meter. So I just need only two grid lines in X and Y direction. 5 meters. 5 meters. These things are optional. Click OK. I don't want plan view, so we will work in 3D view. Go to the define menu, select material properties, modify show material. So I am changing the density from 23 to 0 to avoid the self-weight of a material. So make it 0. Also 2 into 10 raised to 6 or 200 GPa. Change the modulus of elasticity. I will tell you why I changed this modulus of elasticity. Click OK. So I will use the default section of a beam which is defined in this system. Select concrete beam from the properties. And draw the beam. Specify the supports. Go to assign menu, joint, restraints, fixed. Okay. We have to do the same in other direction as well. Joint, restraints. Okay. As we have drawn the beam, we have to assign a load. Select the beam, go to assign menu, go to frame loads, distributed. So as I told you, I have selected, I am assuming 15 kN per meter of uniformly distributed load throughout this beam. So click OK. So the load is assigned. So first let me tell you, to assign the release option, there can be three cases. First is no release, that means both ends are fixed. And second is making a pin connection. And third option is partial release, that means you have to specify, you have to reduce the stiffness of support by some percentages. So let me tell you from where you will go through this option. Go to assign menu, frame, and then release or partial fixity. So you can see there are various check boxes in this dialog box which are for releasing or making 100% pin connection. So one is start point in the section and the other is end point of the section. So you will see when you click the start point, so there will be a value which is by default to 0, which means the stiffness is reduced to 0 and this leads to create a pin connection. So let's do it. First we will run the analysis with no release. Okay, no release means the connection is fixed. So let's do it and compare the value. What is the answer? So let me switch to the moment diagram. So from the moment diagram, we are getting minus 31.250 at the ends and 15.6250 at the middle of the section. So let's see manually whether the answers are correct or not. So I've calculated it already. So for middle section we have a formula WL square by 24, and for the end section, if we are considering a fixed beam which is loaded with uniformly distributed load, so for end section the formula is WL square by 12. So W is 15, L square 5 into 5, 12 from the formula. So minus 31.25 at the ends and 15.625 at the middle. So 15.625 at the middle minus 31.25 at the end. That means our model is working perfectly fine. So let me make it a pin connection. So how will we do it? First unlock the model. Okay, select the beam. Go to assign menu. From frame section we have to select release or partial fixity. So select start point, select end point. I'm not putting any value over there. 0 means by default we are making it a pin section. We are reducing the stiffness to 0. So click OK. Okay. Run the analysis. Yes. Switch to the moment diagram. Right click and you can see now the bending moment diagram is same. It supports the bending moment is 0. At the middle the bending moment is higher. Let's calculate whether our model is working fine or not. So I will switch to the Excel file. So we know if a beam is carrying a uniformly distributed load, so the formula will be WL square by 8. So W is 15 kilonewton, length of a beam is 5, make it a square which is 5 into 5 divided by 8, the answer is 46.875, and the same answer is being generated from ETABS model. So let me tell you how to release the moment partially. So we have already discussed the two cases. Now I'm switching over the third case. So if I want to reduce the movement at the support by 40%, so how will I do it? So for that I have to calculate the stiffness. So as we know, to calculate the stiffness for a fixed beam supported subjected to a uniformly distributed load, the formula is 2EI over L, where E is modulus of elasticity of a section, I is moment of inertia of a section, and L is length of a beam. But you have to make sure length of a supported beam. So E is modulus of elasticity, which you can get from material properties. Okay. Moment of inertia you can calculate from BD cube divided by the length of beam. So for this, what you have to do is D in our case, so depth of a beam is 0.5, width of a beam is 0.375 meter, modulus of elasticity is 2 into 10 raised to 8 kilopascals. Okay, in software we have inserted the modulus of elasticity value in megapascals. Moment of inertia I have calculated 0.00391. Length of a beam is 5 meter. So from stiffness, as you can see, as I was telling you, 2EI over L. So E is our modulus of elasticity, I is moment of inertia, and length of the beam is 5 meter. So from there we have got the value of stiffness, which is 31250. So after calculating the actual stiffness value of the connection, you need to multiply it by the reduction factor, by which you need to reduce the moment. So the reduction factor can be calculated by using the equation, which is n upon n minus 1, n upon n minus 1. For example, you just want to get only 40% moment in the connection. So that means you are going to reduce the moment by 60%. So n here you will use as 40 because you just want 40% of moment in the connections. For example, if you want 30% of the moment, you want to reduce by the 70%, so you just put 0.3 over 1 minus 0.3. But I am going to reduce by 40%, so I have just put 0.4 divided by 1 minus 0.4. So this will give you a reduction factor. So you multiply original stiffness with reduction factor. So whatever the value you get of spring constant, copy that value, go to your ETABS file, select the beam, go to assign menu, select frame and click release partial fixity. So we want to reduce the moment, major moment, by 60%. That means we just want to get 40% value at the connection. So just paste the stiffness which we have just calculated, click OK, then rerun the analysis. Switch to the moment diagram. So see, at the mid we are getting 34.3750. At the ends we are getting minus 12.50. Let's go to our Excel file. So partial frame release for 40% is minus 12.5 at the ends. If you get the ratio of these two quantities, so minus 12.5 is 40% of minus 31.25. So we have reduced the moment by 60% and we are just getting the 40% moment at the connection. So this is how we can release the moment or control the partial fixity at the connections. For more updates, please subscribe my channel and press the bell icon so you can be notified on my next uploads. Thank you and have a nice day.